Hello everyone. Um, how are you all doing? We will wait until 5 p.m. to see if more people are joining. I have no idea how many people are coming actually. There are around like 80 people interested, and let's see how many of them turn up. Webpage. Yeah, this time yes, bifocals, because last time you guys were not able to see it properly, the components that I was using. So this time I'm gonna be using bifocals. Is the sound and the music correct, or do I need to make some adjustments in that aspect? Anuvind, hello. How are you, Anuvind? Muad, hey, welcome back. Yeah, there are a few who are already joining for the second time. More volume from the mic. Okay, I'll see. Okay, maybe somewhere. I'll make it max the volume of microphone. And the music is okay? Because it's weird if you don't have some background music to fill in the traffic sound, and maybe sometimes there is police car and and buses going around, so it might make sound. So as far as I can see, hello, it's starting in a few minutes, right? I'm in different, yeah, sure, it's starting like in five. We are gonna wait until 5:05, 5 minutes extras to see like if more people are joining in, but the exercises we're gonna start around 5:20, so I hope more people are coming in. So we have 1, 2, 3, 4, we have 11 views. That's not bad. 12. Yeah, you see the police car that I was telling you? Well, it's not police, I think it's ambulance. A little higher on my volume. I think it's the maximum. Oh, I have to maybe move the microphone to a different position, or maybe try to speak louder. Yeah. Yeah, I'll try to speak a bit louder. Gabby Garcia. So how many people are, if you want, you can write where you're from or what have you guys studied. No, man, Twitch. I don't know, YouTube. I'm just starting to see how it goes, and I think YouTube is the simplest, because the thing is it's recorded and you can come back and watch it. So if you remember, like the guy, if you were in the previous webinar, you can go to the YouTube channel, and in my channel you can actually go and watch the videos either on video. I think it's on playlist, and you can still watch the previous webinar. So that's why, maybe, I don't know if in Twitch it's possible. Yeah, YouTube is better. You can reach a wider audience. So if you guys can write down where are you from, like maybe what's the time zone, because I'm really I calculated more or less, like there were a lot of Southeast Asian, and there were, so it's, I think in India or around there, it's around 9:30 p.m. so it's not too late. and on the other side in the US it's in the early morning around 10. So I thought this is like a good time to for everyone. uh, so wait, I have to maybe increase the size a little bit. Okay, so Vaibhav is from New Delhi. Okay, perfect. Montreal, México, güey. Ernesto, ¿qué tal? Nima, where are you from, Nima? It's GMT 3. Bangalore, Doha, Qatar. Wow. Indian and graduate in architecture. Tunisia. Hello, Tunisia. Welcome to the group. Yeah, sorry. There are dogs. That's why it's a bit. Um, yeah, I'm really sorry if there are background sounds, and I cannot do much about it actually. Mm-hmm. Yeah, 4 more minutes we are gonna wait, and then we're gonna start the course. Architecture. Bangalore. It's ITS Rookie. From Turkey. Oh, okay. Mm. Yeah, architecture in Turkey is there are a lot of architects in architect students in Madrid from Middle East and Eastern Europe. Mm-hmm. So you guys have like all the plugins installed, and so we have 15. Are you talking about plugins? If you're asking, do I recommend another kind of plugins? For now, we are gonna use Anemone, or I don't know how do you pronounce it properly. It's for looping, but we might use different plugins for in combination. It's not necessary, but if you have it, it's gonna be Weaverbird, so it's really common, and I think if you have been using Grasshopper basics, you would have it installed. Also, I didn't write it in the email, sorry for that. But you can install it like easily. Apart from that, so we are gonna do 2 exercises today, a basic one and a bit advanced. And just in case, like it's not recommended, but if in case you find yourself lost, you can download the file here. And it's a Grasshopper definition. It's for the advanced one, not the basic one. So we will try first manually, and then if you can't follow along, then it's better you can download it. Can you instruct how to install Weaver, because you mentioned we need to have it too. It's easy. It's like you have to download the files, unzip it, and then copy and paste it in components folder. Can you link it to chat? The file are you saying, or the Weaverbird plugin are you saying? I think you're talking about the file, so most probably I can do is okay. Okay, perfect. So I think we should be starting soon. There are 20 people around. Wow, that's nice. Also, I'm not seeing all of them writing on the chat. Okay, no problem. We're gonna just start. All right. Um, so, uh, Maritere, hello. Heva, hello to you. Shara, uh, welcome to the group. Uh, Late joiners, you guys are like 5 minutes late, but no problem. We haven't started yet, but we are just about to start. Yeah, there are a lot of from Control Mod. Nice to have you guys back. It says one file couldn't download when I dropped the file in GH. Let's see if it doesn't work. We can I will find a different way. But it was just in case of emergency. We are gonna do it all together. Control mod is a formation. No formation. No, it's like Grasshopper training center. It's situated in Madrid, and they give a master course. It's like 3-4 months for intense Grasshopper training, and they invite like Arturo and a lot of people who are really into Grasshopper, investigating and writing books and experts. So it's a really nice experience, and you get to see Madrid also. So if you know someone who might be interested, it's highly recommended. Okay, yeah, let's start. So hello everyone once again. Myself Aman, and I graduated as an industrial designer last year here in Madrid, and I have been using Grasshopper for like 3 years intensively, and before that I was using different kind of programs. Because when you use Grasshopper, and if you're not from a IT background like I wasn't, I didn't know coding, I haven't studied information technology in like advanced information technology, coding and stuff. So it's really intuitive because you have visual modules, and you don't have to worry about the coding part. It's a bit more easy to start. And yeah, I have by around 2 years of moderate use, you can attain good skills of Grasshopper. Okay, so I was getting familiarized with everyone. You guys are from almost all parts of the world, so that's great to have you all here. And you can still write if you haven't. Where are you from and what have you studied? But mostly, I think you guys are architects or designers. Okay. The constant here is we have to keep practicing, we have to be patient, and we have to be persistent when we are learning any kind of skill. Because if someone was able to do it, you are also gonna be able to do it just with a bit more practice. So I'll leave it there. So in this one, we are going to talk about Anemone. I'm just going to make sure if everyone has it installed. Do you guys have Anemone installed in your Grasshopper components folder? Yeah, perfect. So Anemone is a plugin that helps you loop in Grasshopper. Looping is like a really fundamental part of any kind of code and information system, where it helps to optimize your code a lot, and you can automate repetitive tasks. And in Grasshopper, surprisingly, there is no natively installed looping option. So this plugin helps us to do that. It's a plugin developed by Mateus, I think Mateus, it's how it's pronounced. You can find more about his work on the Grasshopper forum. So let's fire up our Grasshopper. I'm gonna start my Rhino, and let's start by creating a new file. I'm gonna turn on the bifocals so that you guys can see what's happening. You don't need to do that. Okay, so let's create a point. XYZ point, construct point. And let's say we want to move it by a vector, XYZ vector. And just let's give some values to it. So we are moving it 20 units. Perfect. So what if I want to move this point again to a different vector? So I have to copy it, paste it, and this is gonna be my new geometry, and I have to move it again like that, and the same, right? So it's okay if you have to do it maybe a few times, but imagine I have to do this maybe 1,000 times. So that's where Anemone is useful. So open the tab of Anemone. And we are gonna be using just these two components for now. Loop end and loop start. So let's bring down the loop start, and let's bring down the loop end. Okay. So I don't know if you guys have previous experience with coding. And you guys are familiar with the curly brackets. So it's like this and this, and whatever it's in between is our code. So it's something like that. When we have these two components, we have to tell the algorithm where our loop starts and where our loop ends. So we have to connect this with this to define that bracket, and whatever is gonna be in between, that's gonna be looped. Okay, so let's copy whatever we had it here, these three items, and bring it down to here. Perfect. So to start, I'll also disable all of them so that I can see it properly here. So to start, it asks for repetition, trigger, and data. So let's provide the point as data, and we're gonna use the data as an input for moving the point, and then use the point moved as the output data. Okay, so what's happening is we have an initial point which is going inside the loop, and then we are going to use the point to move in a certain vector, and the output results we are going to use it back as an input result. So this component, whatever which is outside of this, is going to be used only on the first instance, and the next time it's just going to be a loop. Okay, so let's see. If I want to repeat this maybe 20 times, repeat 20 times, so you can see when it's moving. Let's create a button so that we can reset it easily and connect it to trigger. I can even say like 65, and then I'll just change the vector maybe a little bit so that's not so drastic. Okay, perfect. We can hide all of these to just see the point which is moving. And here you have a thing, when you right click it, you're gonna see output after the last and record data. So record data is basically the recorder which we have in Grasshopper native as a native component which records the iterations. So you can actually turn it on here, record data. So now when you do it, it's gonna record the data. Okay, perfect. So let's create a variation. I'm gonna turn this off. I'm gonna create a populate 3D. So we have 3D points. I'm gonna have maybe 5 points, not a lot. So we have 5 points, and I'm gonna create a point container. Hey, seeing you. Yeah, you are a bit late, but you can start from here, no problem. Are you guys able to follow along so far, or am I going too fast? Can you please comment so that I can go a bit slower, and then we can maybe do it a bit longer. And okay, perfect. Let's have more sample points. Ernesto. A little fast, yeah, okay. Yeah, I'll try to go a bit slower in this exercise. So what we are doing is we are creating a population of points, random points, and we are putting it in a container so that we don't see the box. So it's just a point. Perfect. We are gonna bring down the loop start and loop end component from Anemone. You can find them here. Connect the loop. Maybe type 50 repetitions. Connect a button to reset. And we are going to use this data, these points, as the input data. And we are going to move these points randomly. Okay, so let's create a random a vector, x, y, z vector. So we have 3 vectors. Let's copy and paste, copy and paste. Sorry, we can use maybe just one. And we're gonna use the move component. So we have the geometry, all the points. So we have 5 points, and we have to give 5 vectors to the point so that it can move in 5 different random locations. So let's create, can you pan over just for a second to earlier? I'll take a screenshot. You're gonna have the recorded video, so don't worry. Well, if you want, you can have the screenshot. Okay, so we have the points, and we are gonna create 5 random points. How do we create 5 random points? Using the random component. You can find them in the sets. the range for now, let's leave it from 0 to 1, or let's leave it from -2.00 to 2.00. Okay. And create a domain. Stream is locally blocked. Have to catch the replay. Yeah, I'm sorry. So we are gonna create a domain. We can create it like this, or we can also create it like -2 to like that. So both are fine. Here you cannot change it easily, but here you can. So I'll use this one. And how many numbers we have to generate? We have to generate as many number as the points. So we have 5 random vectors. Let's repeat this component 3 times for x, y, and z. Okay. And let's connect the data here. So as you can see, let's maybe reduce a bit the random vectors and reset. Okay, I'll record the data. So as you can see, they are going in the random vector, all of them at the start, but they are continuing to go in the same random vector. Why? Because we are not providing a different random vector in each iteration. So we have the random vector which is in the first loop sequence is the same for second, third, and fourth. So how can we change it? We can change it by connecting it to the value of counter. See what happens in the counter. Counter is it's like a counter of how many iterations have passed. So when I start, so it goes from 0 to 50. Okay, so it's giving me 50 values in each iteration, and each iteration is different. So we can use that as the seed. Okay, a random seed is a random number. It doesn't has a direct correlation, but it's just each number is gonna provide a different random value. Yeah. Okay, perfect. So I can connect the seed to each, the counter to each seed. Okay, and let's see. It's still doing the same. Why? Because we are providing the same seed to all of the random vectors. So what we have to do is, I'm going to disconnect all. So what we have to do is we have to multiply each counter value to a random number, any number of your choice. For example, maybe multiply this by 245, this one by something like that, and the third one by something like that. So what's gonna happen is we are gonna multiply the counter value with these random numbers that we have created, and each time you're gonna receive, as you can see, each time we're gonna receive a different random seed. Okay, so they are gonna be different in each iterations. So let's connect the first one to the first one, the second one to the second one, and the third one to the third one. Are you guys able to follow along so far? Can you please comment? there is around 9 seconds of delay, so I might not see like your response right off. So I'll try to repeat. We have the loops, and in the loop we have created, I think this is creating a bit of confusion. So we are basically creating 5 random values for the vectors, 5 this, 5 of those, and 5 of these. Because if we're going to change here, we are also going to receive different values, okay? Or else there will be a mismatch of data. So that's why we are using the same number of random seeds as the number of points, so that they are like the similar. Okay, perfect. We can hide these, and as you can see now, we are gonna find something similar that we have here in the video. Let's try to create interpolate lines in the vertex. So right now what's happening is we have a list, a big list, and inside the big list we have small lists, and in each small list we have 2 points, one for the first point and one for the second one, and again and again and again. And what's happening when you connect the interpolate component, counter a little bit more, okay, the counter provides a new seed. Okay, so counter is basically like when you repeat a loop, the counter is gonna say, okay, 0 because we are in the first loop, 1 in the second loop, 2 in the third loop, and so on. So like imagine we have 18 repetitions. So when I start, it's gonna go 0 to 18 because each time it completes a loop, it's increasing one value in the counter so that you know in which loop you are. And we are gonna use the value of counter to create a random vector because it's changing in each cycle and we want a random value in each cycle. Coming back to the vertices, so it's giving me 2 vertex in each small list, and if we want to create a line, a tail of the movement of the vertex, we need to flip the list so that all the first points they are in one list, and all the second points they are in one list. So you can use flip matrix. So what it does is it changes from the 2 list on A and B like this, A, B, A, B. So right now the list is like this. So when we flip the matrix, the list becomes like this. Okay, clear? So let's flip the matrix. You can find it here in sets and trees, and let's connect it to vertex. So now you can see we have the lines. I'll hide everything else, and I have the line here. I'm gonna change the number of points and maybe increase the iterations. Maybe say 500 repetitions. Are you guys able to follow along so far? Mhm. Okay, we are going good with the time. Why are you getting an error on the... have you turned on the record data? Maybe you don't, it might be saying you don't have sufficient points. Okay, let's start a bit step by step. So we have a population of 5 points, okay, and we are going to use it as input data to perform an action and use the output of that action as an input for the next iteration. So these points are just helping us in the first iteration, and once it gets into the loop, the output becomes the input, and so on and so on. So that's how a loop works. So the confusion might be especially here, like this part, because what we are trying to do here is we are trying to generate 5 random points, random numbers here, here, and here, which are between minus 0.95 to 0.86 in my case, but it can be anything. So we are saying we want 5 random numbers between this value and this value, and we're going to use it as random vector to move all the 5 points that we have initially taken as input. So it's just moving these points in 5 random vectors. The problem is you cannot get a new random vector in each iteration unless you change the seed. The seed is gonna be helpful whenever you change the value in a random component. Let's see. So we have random component, and it's generating one random number because it's by default from 0 to 1, and we want one random number, but you can say we want 5 random numbers. So it gives you 5 random numbers. And the seed is nothing but just an arbitrary number that whenever you change it, you get a totally new random number. So what we are going to do is we are using the counter, which is going to be 0, 1, 2, 3, 4, and so on, and multiply it by a number, any arbitrary number, but they all have to be different, because if they all are same, it's always going to give me the same random numbers for each vector, and we don't want that. We want totally random vector for each iteration and for each point. So that's why we are multiplying it with 3 random numbers also, to give it a bit more randomness in our summary. And we are going to use the 5 random vectors to move those 5 points. It moves the point, it takes it as an input, comes back, and use the exited point as an input point, and the cycle repeats, and you get an emergent pattern, which is like this noodle-like structure. Like if the vectors are much larger, the record data thing was a big help. Is there a way to slow down the process? Yes, there is a way to slow down the process. When you go to the Anemone, this one, you have in the utility section a time buffer, which basically what it does is it stops the data in milliseconds. So let's say we want to stop it for half a second and then continue. So when I start, you see it's it's outputting in every half second the data. So you can use it, for example, if you're performing any simulation and you want it to wait certain time, you can create a buffer and then send the output. The problem is when it's not working, it's gonna give you an error message. So depending upon what you want to do next might influence your way of working like this. Okay, where was the record data option? It's in the loop end. You click the right button and you have record data. If you have the display icon off, you can even see like when the component is working, it says running. So when you double click, it says paused. And it also says here like constant and record. And if I turn it off, just constant. So maybe it's better to turn off the icons, but for example, right now it's and here if you double click, it starts. I think it's paused. Double click and starts. So you can see here if it's running or if it's paused. Okay, perfect. Now a bit more or less clear. Yes, Xingyu is asking, is there a reason why the random points are skewing in the same direction? Because we don't have a even domain. For example, right now the negative 1.58 is higher than 1.3, so that's why they are moving there. But if we have negative 1 and positive 1.0, let's see if they go the other way. So now they are going the other way. And if we have negative 1 and positive 1, we should be having fairly random movements. So yeah, like they might act crazy depending upon your random values here. So maybe -2 till 2. And as you can see, like the simulation, the loop is still on, and I can still change the value on the go. Like I can change and make it go or not. So you can create complex systems just by interacting with the domain when it's still working. Okay. All of kind of diagonally in the same direction after where still. Is it when I made the range equal? Did you multiply the seed, the random seed with 3 different numbers? For each random component, you have to provide a different random than the other 2. So if we directly connect the counter, it's gonna be the same random seed for all of 3. So by multiplying the counter with some random numbers, we are providing each time a different random seed. Maybe your range is not big enough. You have to, if they're just moving and staying like in a really close compact part, you have to increase the domain so that they can have higher area to explore. So if I say -5 to 5, so they're gonna be the movements are gonna be a lot more exaggerated. So like right now, as you can see, but maybe try -3 3 to minus and to plus 3 or maybe more, depending upon the scale where in which you are working. It might be different. Okay, I think more or less you guys are sure how it's working. Shall we move to the next exercise, which I think you guys have seen on Instagram, this one. So it's basically we have a loft, and we are using the loop component to select the face of each loft and then create 4 lofts. And then in the next iteration we are selecting the 4 loft of one loft and then doing a bit the same. So it's like Inception, like you have loft inside loft inside loft. Okay, so we are gonna see it in details. Mine are all close to each other. That's why, like as I told you, for example, imagine if I had negative 0.5, sorry, negative 0.5 to 0.5, and I turn on them, sorry, negative 0 to positive 0. So if I turn on, so they're also staying the same, like, you know, because my random values are really low or even lower, like somewhere there. So they're gonna stay there only. If I increase the search area, then we are gonna see a bit more entanglement. So depending upon the scale where you're working, it might be that it's happening something, and if it doesn't work, then just try different multiplication values. Like might happen that your certain random values are not generating any good random seed, so maybe try different values and you might expect totally different results. Yeah, try to use the same parameters as a start and explore once you understand the coding. Yeah. Okay, I'm gonna turn off the loop and then let's move on to the next exercise. So let's create, I'll put it in shaded. So let's create a square, something, a cube, something like that. Okay. Please let me know if you guys have started with the next exercise, or shall I go back and maybe clear a few doubts? Loftception, yeah. I'm only seeing like 4 or 5 comments. What about the rest of the guys? Are you able to follow along? Arun Kolla, are you able to follow along? Leonardo, Marite, Heva, yeah, okay, perfect. Let's go, let's go. Okay, perfect. So we create a B-wrap. So let's import the B-wrap. Okay. And let's deconstruct the B-wrap. So when we deconstruct a B-wrap, it gives us the faces, the edges, and the vertex. So we are going to use the faces. So let's say surface, and we're going to create a container for a surface. Perfect. So what we are going to do is I'm going to do it first in Reno, and then you can see. So we have, for example, let's say we have the bottom surface. Okay, first what we are going to do is we're going to scale it, and we're going to move it in the normal of the surface, which means if it's something like this, the movement is going to be perpendicular to the surface. Okay, and after that we are going to create a loft between here and here. Okay, a stupid question: how do I open new window in GH in Mac? I don't know, because I'm not using in Windows. I haven't used Grasshopper in Mac, but maybe the way I'm doing, just turn off everything and then just start at the bottom and you can use it. What is the use of containers? Containers just to make everything a bit organized, but you don't need to. Not just that. For example, if I say curve, let's see if it works. So yeah, for example, we had surface, okay, and if you connect a surface to the curve container, it automatically converts this surface into curves. So now you will have the curves like here. So putting a geometry in the container, if it's compatible, Grasshopper is intelligent enough to change the type of geometry, because it understands what kind of, if you connect a surface to a curve, it says, it knows that. So what you want is use the parameter, the exterior parameter of the surface, and convert it into a curve. Anyway, okay, perfect. So let's start. So let's start Anemone, loop start and loop end like before, connect them together, repeat. Let's not create a repeat number more than 3 for now. So let's start with 0, 2, 3. Okay, so my number won't go further than 3. It's because just to be sure about, we are not gonna crash our Grasshopper application, because this exercise is resource intensive, and the higher you go with the numbers, the longer it's gonna take. So just make sure that the maximum repeat that we can do is 3 for now. Connect a button in the trigger and the data. So we have so what we are gonna do is we're gonna maybe disconnect this, use this brep as the input data. Okay, I'm gonna delete the previous curves. So we have hidden the geometry, and I'm gonna first explode the geometry, and we are gonna have the surfaces. So we have 6 surface. Let's bring down a component which is called evaluate surface. Okay, connect the surface to this point and to the component, and import MD slider. MD slider is a multi-dimensional slider, and let's leave it where it is. So when you connect it, you're gonna see like we have 6 points, and when we move, they're moving but in a random way, and they're not on the surface. So what we need to do is reparameterize our surface. So when you click reparameterize, now you have the points in the middle of the surface. So to see what's happening is when you move the MD slider, you are moving the point on the surface. So this is 0 0 and this is 1 1, and any number in between is gonna be translated into the point on the surface. Until here clear what we have done with the evaluate surface? Can you guys please write if you are able to follow along so far? Any questions in this exercise so far? We have a B-rep, we have deconstructed the B-rep, we are using the face of the box individually, and then we are finding the center point of the box. Clear? Perfect. So it's giving me a few things. One is the point, and the another few which is really important is the frame. So it's telling me where the point is on the surface, which is in the center. Okay, I think it's better like in the center, and then it's also telling me the vector in which the orientation of the surface is situated. So what we are going to do is we are going to scale these surface into smaller portion. So we are going to use scale. What are we going to scale? The surface. We are going to use the center point of each surface as the center for scaling. I'm going to hide this one. Okay. The factor by default is 0.5, but you can put some values here. Okay. So 1 is completely full and 0 is non-existent. So let's leave it around 0 point something like that. And so we have the original geometry, which is here, and then we have the scaled geometry, which is here. We are going to move the scaled geometry to the normal of the surface. So let's say move. What are we going to move? We're going to move these geometries. So right now by default it's moving it into Z direction. So what we want is to move them in the same direction as the frame. So when you connect the frame to motion, you can see that it's moving perpendicular to the surface. Obviously right now, as you can see, you are connecting the frame, but you cannot control the distance because it's just giving a unitized vector, which is just saying like, okay, so this direction, it's 1 unit. So how can we increase and multiply the amount of how much we want it to go further? We can use a component called Amplitude, which you can find in vector. Okay, so we're gonna connect it to the vector and this to the motion, and now when you change, you can control how much you want it to. Can we give normal as its motion vector? The problem with normal is it's just gonna give it the direction. You can use it, there is no problem, and you can also amplify and do the same. Is the same. I use frame because frame not just gives you the normal, but at in which point it is located. So the two are different things, and it's better to use the frame. And you can control it. Perfect. So we're gonna hide first this one, keep this one intact, and maybe hide these two. So we have surface, two surfaces, and now we want to do a loft. Okay, and here the advantage of containers. So this surface, I can either deconstruct it again or maybe use the edges. The best thing to do is just connect it to a curve component. So it's giving me the curve, and I'm gonna connect the moved geometries also to a curve component. Basically, we are converting the original faces into curves, and after scaling and then moving in the perpendicular, the normal of the surface, we are converting into curves. And let's hide it, also hide it, and we are going to do a loft. Okay, so loft here and loft here. As you can see, it's not working because loft works a bit differently in Grasshopper. So we have to give it into two lists, that too telling just use this curve with this curve. And how can we do it? We just have to graft. So we graft it here and we graft it here. Okay, so now we have 6 lofts, 1 2 3 blah blah blah, and obviously when we change anything, the rest is changing. Okay, so far so good. Can you guys please write if you are able to follow along? Any doubts so far? No, if you graft it at the loft component, it's not the right way actually. You have to provide 2 lists and graft them prior to that. And I would also highly recommend to like flatten here and also flatten here. It's just to make sure, because the Anemone component, what happens is whenever it loops, it increases the hierarchy of the list. Okay, so it's better to flatten and let's not have complexity in our code. Okay, because well, it's turned off, we will see it later. And let's join the BRAP. So let's convert all these 6 different lofts and convert them into one. So we have to obviously flatten or else it won't work. So we flatten the loft and we have now one BRAP, as you can see here. Okay, and let's maybe put it into 0 for now. Let's connect this as the input data, hide this, and in this case we don't need a record, because we just want the final result, because if we do the record it's gonna mess up. So let's leave it like it is, and let's go the first generation. Okay, and let's go the second. So as you can see, each time we go and we do the iteration, it's taking a like almost how do you say, like increasingly longer time. So let's leave it for now to 1, 0 and 1, because 0 is also like because we start with this actually, and in the first generation, which is 0, we are getting this, in the second we are getting this, and in the third we are getting something like this. Okay, are you guys getting the same? It's basically data matching when you're doing it. Are you guys able to get what I'm getting here? I'll leave it like that so that you can copy if you are not. Yeah, woohoo. Yeah, for third generation, it's gonna take a lot of time. Yes, we are gonna see how to make sure that they don't intersect. For now, we are just gonna do a basic, and then we start to because now what we can do is the first generation, we want the geometry to protrude maybe 10 units, but in the next generation we want 5, and in the next 2.5. So you can use the counter and divide it by 10, and then you have with each generation the amount of distance that it's have to loft is smaller and smaller. So but now, for now, we are going to leave it like this and then see how we can do it. How did you do the container? What were the components you recommended flattening? So I flattened here in the data, in the starting of the loop. You don't need here, but I did something. Wait. Maybe. Yeah. Okay, sorry. Yeah, so you can flatten it here. You don't need to, but you can. What you have to make sure is you have flatten in the starting and you have flatten at the end here in the loft. Okay. Yes. Mowad asks, what if I want to create a loop which can go for 1,000 iterations, or it should stop once it reaches a threshold, like a volume or a distance or whatever, so yes, when you see the loop end component, you have an exit. So when the exit component receives a true value, it stops. So yes, you can create an exit condition. That's why this is a bit basic on what we are gonna see. Not just that, we are gonna see, because some of you have asked about the ant colony optimization that was in my Instagram account, and in that I have a loop inside a loop, so you can even make 2 loops, and each loop has a exit condition, so you can do that. Okay, so for now, let's for those who have Weaverbird, which is a plugin for mesh subdivision that I use a lot, So in the end, we are receiving a BREP here. Okay, we are receiving a BREP. Then we are gonna convert this BREP into simple mesh. There is a component called simple mesh. You can find it in mesh tab, mesh, utilities, and simple mesh. Yeah, there might be some problems like that. Because of the interpretation of how the faces are oriented. Yeah, exactly. Like that's why I started with a cube, not with like surfaces and merging them, and I am exploding them here itself. That's why when you join them, that is the good thing about Reno, is it changes the orientation accordingly automatically. But don't worry, it's still gonna give you a good way to look at the exercise. So we're gonna do that later. So we have the BREP, and let's convert it into simple mesh. Okay, so this is now mesh. And if you have Weaver Bird, which is here, let's import the thicken mesh thicken component, and we are gonna give it a bit of thickness. Okay, so right now it's 5, but I think that's a lot, so maybe I'm gonna give you something between 0 to 2. So as you can see, in my case, it's generating the thickness inside. It's okay, but if you want it on the outside, you just connect it to a negative value, and it's gonna generate now it to the outside. Okay, and I'm gonna use the Catmull Clark to make the mesh softer, and maybe level 2. Okay, so there we go. I'm gonna create a rendered version and a custom preview. A color swatch. Maybe hide this. Okay. Yeah, that was happening with me also. Are you joining it properly here? Make sure that you're joining it properly. Like you have flatten, and then you're joining the BREP, and you have only one data which is in output. So let's see the second generation. So obviously now you can see the problem, right? The amplitude is really high. So what we can do is we can use the counter to give different amplitude each generation. So for example, in generation 1, we want it to go something like 10. In generation 2, we want it to go like 5, somewhere here. And in generation 3, we are gonna make it something like 2.5. So as you can see, with each generation we are reducing the amount of vectors. How we can do it? Okay, so we are gonna divide the counter width, let's say 10 in my case. Sorry, we are going to divide the number 10 with the counter. Okay, or maybe something less, for example 5. You can try different things, but the problem is in your first generation, when you do it, you are gonna have 0 divided by 7, and you're gonna get an error message. So what we can do is first create an addition so that the first generation is 1, which means like even the counter is showing me 0, the first generation is 1. Makes sense? And now we are going to divide it by 10, for example. Sorry. So in the first generation, we are giving it 10. In the second, we are giving it 5. In the third, we are giving it 3.33. Okay, let's see how it works. And connect it to the amplitude. So first 10, 5, and 3. A bit better than before, that's for sure. Maybe start with a bit lower value, not 10. Maybe start with something like 6 or 7. And it's just gonna be the same actually, because what we have to do is maybe change when it reaches 3, or maybe here divided by 1.5 or something. You have to calibrate. You have to find a better way how to give a proportional random, proportional vector for moving the geometry. Okay, are you guys able to do it so far? And if you want to know how I made the animation, so the way I made it is by, let's say, so first I connect directly this geometry here, so I have and convert the mesh level to 3, so I have this, which is here, and I undo that. No, I disconnect the B-wrap and connect the output, which is this one, bake. So I have this also, move it maybe 45 units. I go the first generation, I bake it, move it 100 units. I go to the second generation and I bake it 150 units. Turn off that. So you have all of them here, and you can create a clipping plane. And when you move the clipping plane, you get the effect. It's just like it slices the geometry in the Rhino viewport. Okay, perfect. Doubts? let's go back to the clipping plane. You just write in the command bar CLI. I think, which version of Reno do you have? Yeah, exactly. You can play with MD slider. In each slider you can give different values. You can also change the amount of scaling, which is here. So if we are in the maybe first generation, and you can change the scaling factor in each generation, and you can also receive like really weird results. So yeah, it's interesting to see how you can generate geometries by repeating the same instructions again and again. Okay, I'm gonna go back here because we have to finish. So we have done this exercise. You can keep writing if you have more doubts. Okay, so I got a lot of questions by you guys. I will try to answer them as fast as possible. 31 NUJ. I really liked your way of solving complex problems by first sketching them out. Could you discuss the process of going behind it and how to start thinking in more mathematical ways while making a definition? Thanks. I think his name is Nikunj. Okay, so generally, yes, the video will be yes, I recorded my screen using the OBS software, which is an open source screen capture program. Sorry. After that, yes, the video will be available later. So going back here, okay. Yeah, so generally I sketch before translating it into Grasshopper, because you just have to think how you want to make the data flow in your script. And sometimes you don't need to know all of it. You can just have an abstract idea, and then you start to work in Grasshopper, and maybe you are going to do something different than what you sketched. So it's a bit more intuitive, and the more you work, the better you get at it. My question is, what plugins are used for product design, and how to use computational design for products design? Okay, so there is no such specific plugin that designs products or stuff, like, you know, the plugins are just a way to interpret the data differently, and this is where your ingenuity comes, where you can use the plugins to manipulate the data in such a way that it gives rise to whatever results that you want. It's basically like Grasshopper is a programming language. It's not a 3D software. The difference is only we have visual modules, and not we don't have to write the codes. And the plugins are like libraries. So in normal coding, you download the libraries and you can integrate them without writing all the code all over again. So it's the same in Grasshopper. So it's not like you have a specific plugin to do products. You can use simulation plugins to see how your product is working. You can use generative and genetic algorithms to generate and evaluate forms. You can add it in NURBS and mesh depending upon what you want to do with it later. So there is a lot of, like, there is no one simple answer to that. You have to find what works best for you, which plugins are really helpful. In my case, I use a lot Weaverbird, I use Lunchbox, I use Anemone, I use Biomorph, which is a plugin which is really interesting. If you can watch the previous webinar, you can see what we try to do some things with Biomorph. So these are a few plugins that I use a lot, and yeah, but I'm still open to see if there are more interesting plugins. Right now I'm investigating about Millipede, which is for structural analysis, and it's also really interesting. Maybe we can do a webinar about either Biomorph or Millipede. Okay, so next question. If you can discuss during your webinar the project with this one, the ant colony, where you have like yeah, something like this. I did it using Anemone. So you use an image. You use an image to populate with random points. You pick one random point and evaluate what is the RGB value of that point, and you move the point in random vectors the same way like we did today in the first exercise. You move the random point, you move the points randomly, and what I did is I created an exit function, which is basically here. So whenever this entrance receives negative, like sorry, let's do it in the first one. I'll turn off this one, turn on this one. So right now it's in the 100th or whatever. So whenever I give it a true value, it's gonna stop. So it doesn't matter how much, like the iteration, it stops. So I did the same in the ant colony optimization. So you start with the point. It can either go 60 moves, that's its lifespan, or if it encounters a color pigment which is not where it was born, it's gonna die. So that's like the exit condition. So it's not so easy to explain it here, but it's not too hard once you know Anemone and you can work with image sampler. Can you show a proper way to have counters in code? Suppose multiple counters in the code which starts at different time. Yeah, so if you have Kangaroo or Firefly, you have timer counter, which is in Firefly, and you can have maybe the steps is something like that, timer. So each second button. So each second we are going to have a different value. So you are asking, for example, the second counter starts only after the first counter reaches 5 seconds. So you want to create a counter which is going to say when it reaches the 5 seconds. So what you can literally do is divide it by 5, and you're going to receive a value. Okay, and No, I think it's better to do it like, maybe you can create a condition. Let's see. In maths, operators, equality. So the first number is gonna be I mean, there is a way to do it something like this, but I won't be, as it's not occurring to me, I will write it to you in your inbox and maybe explain it. But it has to do something like that. So you can divide the number, and then when the remainder is 0, then you move the number to the next phase, and then you have counter like that. Next question. What's the difference between Karamba and Millipede? So I'm getting a question in the live chat. You can write your questions over there. Greetings, a very stupid question. When do we use simplify, reverse, flatten, and graft? Okay, so the easiest way to explain the simplify is when you don't want different hierarchies in your list. You just want one simple list. So you cut the extra branches. Reverse is when you want the list from A, B, C, D to go like D, C, B, A. So that's when you use the reverse. Flatten. So imagine you have 3 lists, each with maybe 2 items, 4 items, and 8, something like that. And when you flatten the list, it takes all the individual component and then puts in a big Amazon box. Like if you have a box, Amazon box, and inside the Amazon box you have small boxes, and each small box you have maybe 2 balls, 4 balls, and 8 balls. And when you flatten it, it will remove the small boxes and put all the balls together in the same big box in one list. So that's flatten. And graft is the other way. So imagine if you have 10 balls in a big Amazon box and you graft it. So what it's gonna do is it's gonna have the big Amazon box, and inside the big Amazon box it's gonna put 1 ball in 1 small box, and so on. That's how you can visualize it. But when you're doing operations, depending upon the circumstances, it's you have to understand how and when to use certain types of flatten and graft. So here we are flattening it because whenever there is a loop, it increases the hierarchy of the list. You can see that here. Maybe like each time it's doing a loop, it's increasing the hierarchy of that list from 0 to 261. So we don't want that. So when you flatten it here, you turn it on. So when you flatten it, you just receive only one list at the end. Also we're just receiving one. But if we don't flatten it, in each generation it's gonna have a hierarchical like 0, 0, and it might create problem if you are using later graft and other kind of list structure. How about pufferfish the next time? Yeah, you can use pufferfish. Is really powerful, especially for mesh editing. What's the difference between Karamba and Millipede? So Karamba and Millipede, they both are structural analysis simulator. Karamba is a paid software. Millipede is free. Obviously in Karamba you have a lot more features, a lot more flexibility, and it's a lot more complex. And Millipede is a bit more simpler. So that's the main basic difference. Example on cell growth from Anemone. Wait, maybe I'll finish first here. Okay, so about a specific design, I have been trying to explore the dialogue between architecture and music with Grasshopper, the multiple ways it can be expressed. Okay, so if you want to work with sound and music files, first you have to install Firefly, which is this one, and here you have a bit of components to import sound. So maybe, for example, sound capture. As you can see, I'm connected with the microphone. Let's see if it works. Toggle. And a timer so that it's updating. So whenever I'm speaking, you can see the value increases, or if I tap in the mic, the value changes. And you can now use the value and connect it to different parts of your Grasshopper definition so that it interacts according to the sound. If you go into the YouTube channel, sorry, in the Instagram account, you have this exercise where you had a mesh that was interacting with music. After that, you can also download Mosquito. Food for Rhino. Mosquito also helps you import some sound values and a lot of different things also, like Twitter, Facebook, and stuff like that. Even Google Maps. So that's really interesting plugin. Could you briefly describe the thought process of origami folding in Grasshopper and maybe some example of common folds? And cellular automata. Okay. Okay. So origami folding. So if you have investigated about Kangaroo, you have hinges. You have hinges in Kangaroo, and you can use this to create folds. So maybe investigate a bit more here. And you asked about examples of common folds. Well, I think there are gonna be, there was also some from NASA, like, you know, NASA origami, I think it was solar panels or something like that. So they were able to like deploy complex structures and then pack it in really small space and then deploy it once it reaches into the space. So it was a really interesting application of folding. And cellular automata. Okay, so cellular automata is like a life and death game, and you can create really interesting patterns and behaviors. So you can do that in Grasshopper. Yeah, sure, why not? You can use Anemone to do it. So you have to work with like pixels or voxels. Voxels are 3D pixels. So maybe investigate a bit more on that side. We have more questions. Cell growth from Anemone. Yes, it was also done using Anemone. The same, instead of adding surface, you start with a big surface and then you start to chop it into smaller pieces in each iteration. You're welcome, Nima. I hope you join for the next webinar. I'm not sure when, but soon. On space filling curves, Can you please elaborate what do you mean by space filling curve or volume? You're saying like cell packaging or circle packing, something like that. Thanks, thanks Ernesto. Yes, you can rewatch the webinar later. It's gonna be in the YouTube channel. Is the animation just always regarded with screen capture? Depends. Like in this case, no. Whenever there was a change in the Grasshopper definition, you can export the image into PNG format. So you can use the screen, no, the capture view, which is a plugin in, I think, in TT Toolbox. Is it this one? TT Toolbox? Yeah, I think it's, no, this one is from somewhere else. It's not showing me, but there are a lot of plugins to capture or export screen image. I think this one, capture view, I think it's a plugin that you can download. It's here. If you see here in the information, you can see where you can download it. So yeah, whenever there is a change, it captures the screen and then exports it into a folder. And later, using Photoshop, you can create video by using image sequence. Yeah, you can also automate baking also. Okay, thanks. Especially with sound one, just showed you how did you capture it in a video. That and the sound one was a real-time capture. I was using OBS screen capture, and then I synchronized the music later. So you are talking about fractals. So you can do fractals using Anemone. There are a lot of examples, and maybe I can do like a small tutorial about it. Thank you, Maritere. Hope you join again. Okay, more questions, because we are almost 1.5 hours, but no problem. I can stay like 5-10 more minutes. There are two books that I would recommend. Was like the same last time. One is Digital Biology by Peter J. Bentley. It's a really interesting book. And the other one is The Blind Watchmaker by Richard Dawkins. Both of these books are really really inspiring and mind-opening, especially when you're into this one when you're into computational design, and in this one when you're more into nature inspired design and that kind of line of work. Can you please give me like 5 minutes once this webinar is over and fill in this feedback form? I'll put it in the link, put the link here in the chat. If you can just give it like 2 minutes. I don't think it would take more than that, but once the webinar is over. And yeah, you can check more work in my website, or you can check more work in Instagram. You can write me about anything that you would like to discuss. Also, what else left? Yeah, and you can go to the Gumroad page, gumroad.com/creative mutation. It's in my webpage also. When you click Grasshopper, when you go down, you can download Grasshopper examples. and here you can download the music file and the previous ones. This one is in Anemone, so you can try and download it, but you might need a extra plugin, and it's written, so don't worry. After that, yeah, that's it. Thank you very much. More questions or anything, let me know. Apart from that, thank you guys for joining in. We were around 24, 25, so that's almost 25% of people. Well, because there were around 100 of people interested, so that's good. Last time we were just maybe 7 or something, so that's almost like 4 times. You're welcome. Just I think in the forum you can write about any special recommendation, or if you want to learn about any special plugin, we might, depending upon the total response, I will see and maybe do the webinar about that. Okay, I think I'll be closing the webinar. You can find the recorded webinar in Creative Mutation. You can visit the YouTube channel, and should be either under playlist or under video. So when you go to playlist, you can see the past live webinar. So I think I'm gonna add it in the same list, and you can see the next one. Okay, had to go the mail link. Just one thing, the webinar was not available if we searched it manually. This one, no, because this is a private link. But once it's done, once it's over, I'm gonna make it public. Okay. All right, so that's it for today. Thank you very much for joining. Please fill the form so that I can know what might be helpful. I'm gonna paste it again. Can you make sure that you can open the form, please? Yeah, there's more to learn from fractals. Yes, I think we haven't. Well, this exercise that we did is kind of like fractals, because the same structure type is repeating again and again. But I do get what you're saying, and maybe it would have been easier to try with a simpler example of like Sprinsky triangle, or some using mathematical formulas and doing something like Fibonacci sequence. Perfect. So thank you very much, guys. See you guys in the next one.